Hello students, and welcome to section 7-5, factoring x squared plus bx plus c. To start with, in example 1, we're going to understand how to factor a trinomial. In the last section we did take a look at using a GCF to do some basic factoring, but today we're going to take a look at factoring looking at a trinomial and the related binomials that multiply to get that trinomial. Let's take a look. Consider the binomial product of x plus 2 times x plus 3 and the trinomial that results x squared plus 5x plus 6. Recall that if we were to FOIL x plus 2 times x plus 3, first would be x times x, so x squared. Outside would be 3x. Inside would be 2x, which in turn adds to 5x, while 2 times 3 last multiplies to 6. So what we're going to go ahead and do is we're going to kind of work backwards, so to speak, from the trinomial back to the two binomials to start with. The product of the second terms of the binomials is equal to the last term of the trinomial. And as it's going to be broken down, as you can see, the foiling they've already done for you. 2 times 3, of course, is 6. 2 plus 3, of course, is 5. So like I said earlier, when we FOIL, we do in fact end up with this particular trinomial. And you can kind of see already that the sum of the second terms of the binomial is equal to the coefficient of the second term of the trinomial. We can see then from there, again, simply taking 2 times 3 giving us 6, 2 plus 3 giving us 5. When factoring a trinomial, you are working backwards to try to find the related binomial factors whose product equals the trinomial. So we're going to go ahead and we're going to factor a trinomial of the form x squared plus bx plus c as x plus p, generically speaking, times x plus q, if p times q equals c and p plus q equals b. In the context of what we just did, 2 times 3, that is your p times q, which of course is equal to 6. And 2 plus 3, in other words 2 plus 5, or 2 plus 3, pardon, yields 5. Your p plus q yields 5. We are eventually going to start with a problem where I give you the trinomial, let's say, and you have to figure out the two binomials to start the problem. So here we go. What is the factored form of x squared plus 5x plus 6? So, identify a factor pair of 6 that has a sum of 5. So we're trying to again think what two numbers multiply to give us 6, but also add to give us 5. Start thinking. Factors of 6 and sum of factors. In this table we know that 1 times 6 is 6, but 1 plus 6 is 7, not 5. 2 times 3 is 6, 2 plus 3 is 5. So yes, that works. Those are the two factors that we will be using in context. The second term of each binomial is a factor of 6. These two factors add to 5. So again, 2 plus 3, of course, is 5. 2 times 3, of course, is 6. So, if you factor using algebra tiles again, which we've done in the past, the correct factor pair will form a rectangle. X plus 3 and x plus 2. In other words, take the value here, plug it into a binomial, as you see here, well, x plus 2. And then, of course, with 3, same thing, x plus 3. So, in the context of an algebra tile, the left depiction highlights that you've got x plus 3 on the kind of topmost portion, where x plus 2 is on the side portion. X by x, that's x squared, but you're adding 2 in terms of this, again, rectangle that has a dimension of x by 1. You have 1, 2 to be added to x, so x plus 2, and on the other dimension it's x plus 1, 2, 3. Again, your 3 rectangles, x by 1. The remaining set of squares are all 1 by 1 in dimensions, so that you can see that x plus 2 times x plus 3 multiplied together, of course, yield x squared. and you have 1, 2, 3, 4, 5 x's, and then 1, 2, 3, 4, 5, 6 of just singular squares. So all of those added together do in fact yield x squared plus 5x plus 6. You can reorient this representation, where if instead you made this side x plus 3 and this side x plus 2, you're still adding x squared plus 1, 2, 3, 4, 5 x's, and then 6 single squares. So of course you can reorient and get the same result. The factored form of x squared plus 5x plus 6 is x plus 2 times x plus 3. The first term of each binomial is x, since x times x is x squared. And you can check your work, of course, by foiling this again, such that, of course, x squared plus 3x plus 2x plus 6 simplifies as the original problem, x squared plus 5x plus 6. So again, we are working backwards, looking at this quadratic trinomial to get this relatable, really product of two binomials, as they show using algebra tiles. Algebra tiles are not necessary, certainly on pretty much any problem, but I do like how you can kind of visualize the resulting product of two binomials, x plus 3 times x plus 2. Next, example 2. Factor x squared plus bx plus c when b is less than 0 and c is greater than 0. So here's your quadratic. It's a trinomial again. Quadratic because it's a degree of 2 again. 3 terms, therefore trinomial. So x squared minus 11x plus 18. b, as you can see here, as negative 11. C as positive 18. The a value, technically, we're going to see later here that the coefficient in front of x squared is your a. In this case, is simply just 1. So there's a 1 technically in front of x squared that you don't have to write. But note that that's a part of our process here. First up, identify a pair of factors, or a factor pair of 18 that has a sum of negative 11. So again, we're going to try to think what two numbers multiply to 18 and add to negative 11. In this particular little table, we'll highlight that same idea. Factors of 18 and sum of factors, hopefully yielding what we want, of course, negative 11. So if we do the math, negative 1 times negative 18, those two multiply, of course, to positive 18, but they add to negative 19, so that's not obviously what we want. Negative 2 and negative 9 multiply to positive 18, and yes, they add to negative 11. So those are the two values that we're going to use in context. In other words, negative 2 and negative 9. I'll say it again. Negative 2 times negative 9 is 18, while negative 2 plus negative 9 is negative 11. So far, the problems we've done haven't had a lot of combinations to look at as far as the pairs. You will have to go through trial and error, going through a litany of possible factors to see if, in fact, the two numbers multiply to the number you're looking at here, for example, but also add to the number that you're wanting, as we saw again with negative 11. Because b is negative, in other words, negative 11, and c is positive 18, inspect only negative factors. So again, a negative times a negative. Even though these are more factor pairs for 18, there are more factor pairs, there is no need to continue once you find the correct sum. So as I said earlier, you're going to have to go through a litany of factors, for example. What I didn't test, for example, as I didn't test negative 6 and negative 3, right? Negative 6 times negative 3, for example, is 18, but of course they don't add to negative 11. So they didn't even write that as an option, because once they landed on the two values that they knew were going to work, they stopped. So the factored form of this quadratic trinomial is simply x minus 2 times x minus 9. So again, we're working backwards, so to speak, by unfoiling, I guess you could even say, the original problem. To check your answer, yet again, we can always foil. So if we take x minus 2 times x minus 9, x times x is x squared. X times negative 9 is negative 9x. Negative 2 times x, negative 2x. Negative 2 times negative 9, positive 18. These two middle terms, of course, again add to negative 11x, so of course your answer checks. The original problem was in fact that quadratic trinomial. So the final answer, again, x minus 2 times x minus 9. This is called factored form. X minus 2 is called a factor. X minus 9 is called a factor. Example 3. What is the factored form of x squared plus 5x minus 6? So for this problem, b is not necessarily negative or positive, they argue. It's just c that we're identifying as negative. B could be positive or negative. Doesn't say anything specific with b. C, though, they say must be negative. So negative 6 to kind of finish off the quadratic there. Identify a factor pair again of negative 6 that has a sum of 5. So think, two numbers that multiply to give you negative 6, but also at the same time add to give you positive 5. So the table is set up accordingly. You've got factors of negative 6 and sum of factors of negative 5. 1 times negative 6 is negative 6. 1 minus 6 is negative 5, not positive 5. So we're going to go ahead and take a look at another pair, which again they stop at once they landed on the number pair that they wanted. In other words, negative 1 times 6 is negative 6. Well, negative 1 plus 6, of course, is 5, which is in fact the sum or b value. Okay. You could have also have tested 2 and negative 3, or 3 and negative 2. Right? 2 times negative 3 or negative 2 times positive 3 is negative 6. But if you add 2 and negative 3 or negative 2 and positive 3, you won't get 5. Because c is negative, the factors will have opposite signs. So one is positive and one is negative. And of course, they landed on negative 1 and 6, so they stopped. And noting, of course, again, that they add to 5 and multiply to negative 6. Again, the factored form, when you put it all together, noting the original problem, ends up being x minus 1 times x plus 6. Again, your two factors in the final factored form. Example 4. Factor a trinomial with two variables. How does multiplying binomials in two variables relate to factoring trinomials? Well, as we can see, we're going to go ahead and take a look at a product of two binomials. Consider the following binomial products. Noting here that we've got x plus 2y times x plus 4y, which if you were to FOIL this, x times x squared, x times 4y, 4xy, 2y times x, 2xy, which then adds to 6xy because they're like terms. 2y times 4y is 8y squared. If you then noted, well, in this example, foiling this as well, you get this quadratic trinomial. First, outside, inside, last. Adding and combining terms there, you see x squared plus 2xy minus 15y squared. Please FOIL to check that answer. And then last but not least, you can see there that we've got two more binomials multiplied, leaving you with this quadratic trinomial. Please check by FOILing to see if in fact that works for you. It should be that particular quadratic trinomial. Each trinomial has the form x squared plus b times xy plus cy squared. Trinomials of this form are factorable when there is a factor pair of c that has a sum of b technically. So again, the idea here is, and I'll just pick maybe this first example again to highlight. 2 times 4 is of course 8. 2 plus 4 is of course 6. Because we are in fact identifying with two variables, remember that your middle term is not just 6 or 6x. Technically it's 6xy. It's not just 6, of course, it's got everything, 6x and y. And then 8y squared stems from the idea that you're taking y times y, so of course it's 8 and y squared. Let's move on. What is the factored form therefore of x squared plus 10xy plus 24y squared? A little bit more complicated, but the idea is the same. Identify a factor pair of 24 that has a sum of 10. So two numbers that multiply to 24 and add to 10. So we'll go through. We've got 3 and 8 that don't work because they do add to 11, or they add to 11, pardon, but they multiply to 24. We don't want it to add to 11. We want it to add to 10. And you can see, of course, 4 and 6 work. Please go ahead and check this answer. As we kind of progress here, the factored form ends up looking just like that.